must be a square. I have one more. Let's see. X. Now this one, the triangle that you can see, is 1 minus x squared. So that means hypotenuse must be 1. Hypotenuse is 1. And this one is x, of course. So 1 squared minus x squared. So 1 minus x squared. And this is theta.
This one's hard to tell. I guess I see it. It's at the bottom now.
Yeah. Now let's start with sine and cosine until you see something that you can replace. If I say sine theta equals to x over 1, which is x. Okay. So x, oh, that's good. I got x. X is sine theta. That's easy. I can replace it. And then dx equals to cosine theta. D theta. Okay. So now what we do here, I change x with sine. So sine squared, it becomes sine squared theta over.
Will we say that just tan theta? Does that work? Opposite over cotangent theta.
So which one?
Like, because if it's adjacent, it's the 1 over x squared, right? And then opposite, it's x. So is it tan then? Can we just say it's tan theta equal to? No, because it's only x, right?
Right. Yeah, I know what you mean. But that's not, yeah, if it was x over that, then you can say all of it is just 10. Yes, that's a very clever, but it's just x squared over that.
That's right, you can all I see. Okay.
That's very good. Yeah, you're right. Because x over that is, but you can do it. You can say that x over, just genius. 1 over x squared times x. And then this is 10. But then this becomes sine.
Becomes sine. Because you said sine theta is equal to x, yeah.
But I'm not sure because it's multiplication, then we have to use.
Yeah, that might not. Okay, let's do your method here.
Well, I like the way that you look at it. Yeah.
Okay.
So let's see. Now I want right here 1 minus. So change x squared to sine squared. That's easy. And then change dx to cosine theta d theta. But I think you know that 1 minus sine squared is cosine squared. Yeah.
Yeah.
So
no,
sine squared, change that one to root and then cosine squared. And then cosine theta d theta. Now root cancels a square. And then cosine cancels cosine. So all we left is sine squared theta and then d. Now we need to integrate this one. There is 1 sine squared theta, okay, equals to 1 over 2 1 minus cosine 2 theta. Integrate 1 over 2, then 1 minus cosine 2 theta d theta. From now, we can bring the coefficient out, so make it easier. Then use the properties, so that becomes integrate 1 d theta minus integrate cosine 2 theta d theta. 1 over 2 times integrated of 1 is just theta. Then integrate of sine, cosine is sine, but it's 2 theta, so we divide by 2. Then plus c. Did I do it correctly? I just read
the same thing.
Yeah. Now you remember how to get. We need to go back to our triangle. The triangle was like this. Hypotenuse was 1. The opposite was x. The adjacent was root 1 minus x squared. So 1 over, instead of theta, I write arc sine of x. Because it's x over 1, yeah?
X over 1.
Like sine theta equals to opposite over hypotenuse, which is x. So that means theta equals to arc sine x. Now, sine 2 theta. Then again, we don't know sine 2 theta. You need to remember another property. It's called double angle. Sine 2 theta equals to 2 sine theta cosine theta. So now I'm going to do this one. So 2 sine theta. Sine theta is x. We already know. So it becomes 2x. And cosine theta is root 1 minus x. Root 1 minus x squared over 1, yeah?
Yep.
The triangle, from the triangle. Adjacent, hypotenuse. And then over 2, the 2 is in the plus c. Now 2 cancels 2 here. So what is left is 1 over 2 arc sine x minus x root 1 minus x squared plus c.